as Eric said, I work from Bell Labs, and I presenting here the project that's again on ICN. So this is the outline of the presentation. First of all, I will give a very brief introduction on ICN, as most of you probably know something about it. Then I will introduce one of the use cases that we mostly analyzed in our project, and see how programmable networks can be used in order to deploy such a technology inside the current networks. So basically ICN, as someone said before, it's basically naming objects and moving objects or data using their name instead of their location. So we have name-based operations, interests or requests are routed in the network, and data comes down from the originate server or an intermediate cache to the requester. So with this, we enable connectionless receiver-driven data delivery. So meaning that receivers express requests to the network on certain data, and the data comes down from the network to the receiver. We have, as I said before, in-network caching that basically helps the network in delivering the content more timely. Let's say, for example, if two users asks for the exactly same piece of data in two times very close in time, the data will be stored very close to the requester. So, for example, here the second blue node in the network. Then also we have built-in security, meaning that data are securely bound to their name, and so that the receiver, the user, the one that will use the content will be able to verify if the content he received or the data he received is exactly the data that he requested. So during our project we analyzed different use cases, but today I will present just one. That's the mobile backhaul. We realized using some measures we get from a major operator in France. You will get probably which one at the end of the presentation, seeing the partners. We measured basically the data that were seen inside the backhaul architecture, analyzing web browsing, dividing them into web browsing, audio, video, and YouTube. That measure obviously is from about 2 years ago, when before YouTube closed. Moved to HTTPS. So now we will not be able to repeat again these measures, but gathering those information, using those information, we realized that ICN have an opportunity to be introduced into the mobile backhaul, because there are many data that are requested at least twice in the mobile backhaul. So basically, if we look at the number here, we have, for example, for YouTube, 80% of the traffic that's requested more than one time during one day. And basically, using this information, we estimated the amount of cache that we would need in order to reduce the traffic flowing inside the backhaul. Because as someone said today, the backhaul is a very difficult place in which we have to, right now we have to increase the bandwidth in order to serve more users. So, and the numbers are, I would say, quite impressive, because we can reduce up to 95% with few gigabytes of caches deployed inside the network. And ICN is a technology that can enable this in-network caching, in this case in the backhaul. So ICN has been criticized a lot because it has been seen as a technology that need to be deployed as a clean slate approach, meaning that you need to replace the existing hardware. And in some sort of, and it's, let's say, true indeed. But what we try to do in this project is to analyze how current technologies or the trend that we are seeing in today of virtualization and moving everything to software, how we can exploit this trend in order to enable the deployment of ICN technology or part of the ICN technology inside the current network. So, as I said before, doing this, ICN will bring some benefits to the current networks, namely the built-in security, as I said before, efficient usage of network resources, traffic reduction and localization, and more and more and more. So in our project, we tried to analyze two different solutions for doing this transition to the ICN. First, exploit current technology with minimum modifications. Sorry, for example, exploiting software-defined network. Or introduce a novel data plane on which we at Bell Labs are currently working outside of the project, and in order to enable the information-centric networking technology, as well as other layer 3 or more higher level services or functions. So regarding SDN, what the challenges are being able to deploy the solution, the ICN solution, or part of the ICN solution, in this case in network caching, directly being in the current network, being compatible with current standard, for example 3GPP for the mobile backhaul, and so on and so on. There's an example of the today's backhaul topology, in which we imagine of deploying different open flow switches and enable some cache and DPI services inside the SDNs open flow switch. So we actually built a prototype using whose topology is represented at the bottom of my slide, in which we connected a client with an SDN controller and a cache server. We do DPI inside the SDN switch, and we contact the cache rather than contacting the original HTTP server in order to exploit the locality of the content. So, and this will bring, on one hand, some of the ICN functionalities, some of the ICN benefits to the mobile backhaul, and on the other hand, it will be the less, I would say, painful solution in order to deploy such technology, because we will not have to replace as much network components as in the other solution. I will show later. So this is the other solution at which we are currently working. So basically, the idea is of developing a modular data plane platform in which we are able to deploy different kind of services, not only layer 3 services. The idea is to have this modular data plane that's able to combine different modules among them in order to build services, and the objectives are of being reconfigurable, reusable, reuse different modules for different functions, and deliver, let's say, fast packet input-output primitives to the application. And obviously exploit the current, let's say, orchestration technology in order to build such services in the network devices. But with this, we will probably have to replace many different network devices, and we will have maybe probably more expenses in order to deploy the ICN solution. So this is on the bottom of the slide. You can see an example of the kind of services that can be deployed using our modular data plane platform. So in this case, it's a ICN that we divided in different functional blocks that perform different operation of the ICN architecture. And for this solution, we have the advantages of having the full ICN solution, meaning that data and requests for data are forwarded in the network using the name. So the network know exactly what's flowing inside the links, and can take decisions based on that. So for example, use different caching strategies, use different forwarding strategies based on the name, and this kind of things. But on the contrary, we will have to replace probably some of the network devices in order to equip them with the hardware that we would need for this architecture. So in conclusion, we had an experimental evidence of ICN benefits. We also, as I will say later, had some experiments on that, and we evaluated two different solutions that can be used in order to integrate the ICN technology inside current or future networks. And obviously, we have to carefully have a business analysis of the impact of ICN, so evaluating, for example, if the expenses that we have to take in order to deploy such a technology will give us the results that we believe it will on the bandwidth saving and reduced cost that of which I talked before. Also in the project, as I said, we had an ICN large-scale experiment on a backhaul, mobile backhaul-like topology, in which we deployed hundreds of nodes, and we used the realistic traffic taken from the backhaul, and we evaluated the amount of gains in these situations. We also had some work. We also did some work on cache, evaluating the cache placement in a mobile topology, and also studied, let's say, packet level cache. That's a key enabler for ICN technologies, because requests arrives with at line rate, so meaning that we will receive many and many requests during in the network, and the node need to be the ICN node will need to be able to treat those requests as fast as they arrive. And finally, we also built a mixed simulation and modeling cache dimensioning tool in order to reduce the time needed to simulate ICN or network of caches, and evaluate where to place the caches. So those are the partners that participated to the project, as Bell Labs and Orange and Telecom Paris from Paris, sorry, and University of Trento and KTH here in Sweden, and University of Trento, obviously in Trento. So thanks, and if you have any questions, I will be happy to answer.